Artificial intelligence, is the new technology that's here to steal your art, steal your job, and steal your significant other. Lucky for me, it cannot steal what I don't have, so I'm safe for now. But still, the internet seems to make this new technology seem pretty scary. It's either you love it or you hate it. But let's be honest, the world is never this black and white. And since I'd like to be an informed gamer, I wanted to take a look at this AI thing in the context of video games and then decide how I should feel about it. So I did what any other normal person would do and bought 2 giant textbooks on artificial intelligence. And let me tell you gamers, I was really surprised to open up this book and see that it's talking about Pac-Man, a game that released in 1980 as an example of AI in video games? Let's start with the very basics. What the heck even is AI? Well, artificial intelligence is what it sounds like. It is something not naturally occurring that displays elements of human intelligence. Things like memory, pattern recognition, and learning. And in the world of coding, that usually means there's some sort of machine learning algorithm at play. So then, what the heck is a machine learning algorithm? The short answer is, it is some code that has been trained on data and then makes predictions based on a specific process for new data. Here's a very simple example for you gamers. We have a dataset of all Pokemon, their stats, and their Smogon tier. Then we can pull up this machine learning algorithm called the k-nearest neighbor that works in a very simple way. You tell it, hey, look at the 5 closest Pokemon in terms of stats, that is your K, and pick the most common tier from that group. That should be your tier 2. That's it, that's the algorithm. So then when Game Freak releases new Pokemon for Generation 10, you can take their stats, look at the closest K number of Pokemon, and get a good idea of what tier they'll be competitively. Now you might realize that this is not perfectly accurate. Things like types, move pools, and abilities can greatly influence a Pokemon's tier. And you'd be correct. KNN is a simple machine learning model that doesn't require too much computation, so it's great for simple situations and stats. But to account for all of these extra factors, we'd have to use something more complex, like maybe logistic regression or a neural network. So how does this whole fancy coding stuff fit into the world of games? Well, unless you're playing exclusively against other human players, the game designers will need to implement some level of AI to make the NPCs seem like somewhat intelligent creatures that exist within the game's world. The only other alternative is to have a random number generator that spams random stuff at you, you know the meme? That would be games without AI. So let me give you some more modern day examples of how AI is used in games. In Splatoon, we have this PvE mode called Salmon Run, where you take on hordes of salmonids, splat the big bosses, and deliver the golden eggs they drop, all the while trying to do that without getting your team wiped out by said bosses. Each of the big boss salmonids have different attack behaviors that can make them seem somewhat intelligent, artificially intelligent. For example, the Stinger, this guy standing on top of the Tower of Pots, he will always target the player that is the furthest from its location. Then we got the Steelhead, he's got a big bomb that he throws from his head, and he will slowly approach the closest player until it gets within range, locks in where it'll throw the bomb, and then does the attack animation. He seems somewhat intelligent, but he's actually artificially intelligent. While people are playing this game, they aren't thinking about the algorithms that give these bosses their behaviors, but instead take notice of these behaviors themselves. And that's the case for the majority of AI used within video games that have some sort of computer-controlled enemy interactions. It's just a bunch of algorithms and code that make these enemies seem like they have some level of intelligence. Pick any video game and you'll notice these patterns of behavior. That is AI in video games. There's also this whole index page for different game types, but I'm not gonna cover those. Instead, we're gonna switch over to another major use of AI in video games, which is during the development process, and it's more backhand, so it's not something that players interact with. Algorithms like procedural generation are core parts of some video games like Minecraft. In essence, they give some sort of rules about which things can spawn where, and then let a random number generator spawn those things. This way you don't have houses spawning in the middle of trees, or inside of lava. You know, you've played Minecraft, you've seen how things generate. But Minecraft is not the only game that uses procedural generation, and it's also not the best example because it's used within the game, but a lot of game designers use them while making the game. A great example of this is actually PlayStation 5 Spider-Man games. They didn't just go out and scan New York City or make it from scratch for these games specifically, but instead created a procedural generation algorithm to create a city that looks and feels a lot like the real New York City. Of course, there's a lot more steps and design choices involved, but at its core, AI was there used to help make the game game possible. Which made me realize that's why this technology is getting so hyped up by people. If someone had to go into Blender and make New York City from scratch, it could take them years, if not decades. I don't know, I never finished the donut tutorial. I have no idea how long it takes to make a city in Blender. But either way, we can both agree that using certain algorithms as tools in the design process could make it possible to create games with much bigger scopes or in a much shorter time frame. While researching this game, I also found out that a lot of developers will use simple generative AI to fill in the blank page at the start of development, or create placeholders to better understand what might fit or just needs improvement. You know, things like image generation for generic goblin enemies, a random upbeat tune to see how well it fits in the area, or even an AI generated voice to decide if dialogue sections are too rambly and intrusive to the flow of the story. As a creator myself, I know how intimidating the blank page can be or how frustrating it is to make changes once already in production, so I can understand why and how some of these AI tools can be very useful in the early stages of development. And from what I hear, a lot of the time these AI generated things are just temporary placeholders that get completely deleted or replaced later on in the process. But that made me wonder, what about these more mainstream AI we hear about? You know, the ChatGPTs and Stable Diffusions of the world. Well, as it turns out, these tools have a better use than just helping kids cheat on their coding homework or degenerates spawn in thousands of sexy images of their anime waifus. Instead, these tools can and are being used to design some pretty creative video games and push the boundaries of what is doable within a video game. One great example of this is an indie game title that reached out to me a couple of months ago, Gug. It is a roguelike video game that uses large language models and image generation to give players infinite possibilities on their roguelike adventure. At its base, you go through the game collecting these blank gugs and give them a 12-letter string of text to upgrade them and give them special powers. So if you type in Pikachu, it'll give you a yellow gug that does electric-based damage. Pretty cool. And this also means you can do all sorts of themed runs or challenges. Maybe you can only use words that start with the letter K, or only words related to a specific topic like Monster Hunter monsters. And after playing through the demo version of this game, I was pretty impressed with how creative the game actually was. So me being me, I asked the developers if I could interview them about some of the design choices and AI tools used while working on the game, and lo and behold, they agreed. If you would like to see the full interview, I've posted a link to it in the description of this video, as well as on my Patreon page, available to everyone for free. Let's begin with an introduction. Who are these guys?
I'm Marlon. I work at Martian Lawyers Club, and I'm working on the game Gug. And my main work that I do on Gug is the game design, the art direction, and the creative direction.
And I'm Kamen. I also work at Martian Lawyers Club. I'm responsible for the operations and business development.
So, what is a Gug?
Gug is a roguelike creature battler. It's kind of in the vein of Pokemon meets Inscription style lane-based combat with a little bit of scribble knots in there where you can type anything you want. And when you evolve your creature, you can type anything you want, and then that gives you a brand new creature that's fully functional in the game, new visuals, new effect that's never before been seen. So you kind of assemble this team of these guggy little organic globby creatures, travel throughout the world, and because it's a roguelike, when you die, you start over, and it's just a game of just weirdness and exploration and creativity.
What was the inspiration for the game Gug?
I think first and foremost, definitely the technology, which I know Kamen can speak about a little more on how all that works. But yeah, definitely as soon as you start thinking about like how you can utilize AI in different ways and in ways to make a unique game that can only be made using AI in real time, your mind starts running with ideas. So initially the idea was kind of like a CCG, like similar to Hearthstone, and then using this technology, and then from there it developed into Gug.
What AI or machine learning models were used for developing the game?
So we use a variety of techniques, but the two most prominent ones are definitely large language models, LLMs, and diffusion models. So the former large language models is responsible for text and code generation, and the latter is for producing the visuals for Gug. We also use like a variety of standard NLP techniques like embeddings and similarity search for selecting Gugs and populating the world, to make sort of like each run varied, but also sticking to a particular theme.
What is an LLM?
Large language models are basically text predictors. Given a prefix of text, like a sequence of text, they generate text to follow. Right, so if I give you the text, the capital of France is, then the LLM tries to sort of like output some text. And what has been very interesting to see in recent years is that if you give it a lot of data to train on and ask it to do the best job of trying to predict, it will output Paris, right? So it learns factual knowledge through trying to be able to do a good job of predicting textual data, right? Because the internet is full of the same statements, the capital of France is Paris, and doesn't have as many statements that say the capital of France is Lisbon, for example. It sort of like learns with huge quotes around it about the sort of like capital property of Paris. So based on this, the vast amounts of textual data that's available on the internet, LLMs have made like huge improvements in the recent years of being able to store and retrieve facts and also build up associations, right? We think about it in the space of GUG, for example. When the player types in something such as firefighter, they want to get an ability that has some connotation to firefighting. And LLMs are especially apt at this. They know what the various properties of a firefighter is, such that they can produce a piece of text that is somehow associated to firefighting. So that's one aspect of it, the text generation. And then the code generation is given an ability described in text, as you would see like on a Yu-Gi-Oh! Or on Magic the Gathering card. You want to make that function in your game. And that requires for you to write code. And it turns out that LLMs are also very good at writing code. So you can sort of set up the framework where you tell it, I want this ability to work in my game. What piece of code do I need? And again, because of the vast amounts of data that is available on the internet, most often sort of like what programmers call the doc string followed by a piece of code, is being able to learn this mapping between natural language data of what a piece of code should do and the corresponding piece of code, such that when you give it a new directive, a new requirement, like a request for an ability, it's able to produce the code to implement that ability.
Okay, so when you're playing the game, what this transforms into is the game gives you a little prompt to type in a bit of text. You type in the text, and then it takes this text, uses the first LLM model to basically match that to effects that would be related to that text. And then it uses the second model to generate the code that actually makes the effect work in the game, right?
Yes, that's correct, with one more caveat, which is the ability has to make sense in the game. So it's a combination of the keyword that the player provides and the context of the game. Mm-hmm. And then for the code, again, it's sort of like the effect that's been generated and the context of the code base is given to the LLM.
How do you keep track of all these GUGs?
But whenever a GUG's created, we seed it. So we now have this database of like 250,000 GUGs, I think it is. So when someone types in the same word, that GUG's already been made, we bring it up. So we're not creating a new GUG every time. It saves us a little bit too.
Why use artificial intelligence to make the game in the first place?
As Marlon mentioned, we currently sit at 250,000 GUGs made by our players. So I sat down and did a quick calculation. If each GUG took a minute for an artist to make, a minute for a game designer to define the ability, and a minute for the programmer to code that up, that would be a year of uninterrupted drudgery for all GUGs so far to be made. Right, so this is not interesting work. This is just the same thing over and over and over again. So if we were to imagine this scaling to 10 million GUGs, which we're hoping to get at some point, you can imagine sort of how much human effort that would require. Instead, we'd much rather have people's creativity be expressed in setting up the framework that underlies the generation and have the game be populated with the player's creations, right? Enabling the player to express themselves in a way that the game designer cannot anticipate. Whereas the developers and the creative side of the game design can be spent in trying to set out the overall vision and the framework in which the players play and have the experience.
One more thing there, you brought it up earlier, Common, that these models have a large amount of information in them and knowledge. And I think that's a big point too, is there's things that I don't know that players want to reference, right? Or there's things that we know that the players don't know that they want to reference. So say someone references something very specific, like a specific landmark in their location, that country, right? This understands it and knows what it is and can make a GUG about it. So that's really helpful, because then that means we can have all sorts of really niche GUGs and content you wouldn't expect to have in a game that players can just add in based off of their kind of backgrounds and their experiences in the world.
Were there any unexpected outcomes from using this design method?
Very early on, we kind of came up with this design decision. As we're seeding these gugs and storing them, we have this growing database. So instead of again, going in by hand and making gugs, we can pull these gugs that players have created down as the enemies and thematically group them, look at what gugs are related and work together, and then set them down in a zone that the player fights against. And just we didn't fully predict it, but it actually had this really cool effect where now every time you log on to Gug, the game has evolved and changed while you've been away, just because other players have been interacting with it. So it's forever growing, it's forever changing, and you then always come across these weird Gugs that other players have made. So it's like a growing game. It's pretty cool.
What was the biggest design challenge when working on this game?
From the get-go, we've always said we wanted to embrace the chaos, basically. There's always going to be a player who's going to figure out how to come up with the instant win Gug. And there's always going to be these hysterical Gugs that are actually evolve into a negative for you and make you lose the run and maybe even make you instantly lose. We always wanted to embrace this chaos, so that's why it's single player, right? In a PvP setting, it may not be as fun competitively to go against an instant win Gug, right? You just happen to not go first, so you lose. And that's why we also did a roguelike, because we think that constant restart mechanic works well for a game where you're just going to die and get destroyed. But something we kind of learned during the process is we've had to keep everything very modular in the design. So when you attack an empty lane, right, some coins drop, and it's just a fun pickup. And then we realized very quickly a player once got 1 million attack, and the amount of coins that drop is based off the attack. So they attacked an empty lane, and then it tried to spawn in 1 million separate coins, right, and it crashed the game. So we have to kind of be very predictive as to what can come up in the game and how to develop it in a way that isn't going to break or crash, while also trying to put in as few safeguard rails as possible so that players can still get this chaotic experience if they want to.
How did the use of AI impact design decisions for this game?
But initially we had this idea, because you asked, can you evolve a Gug that's already been transcend a Gug that's already been transcended. And initially we had this idea that you transcend a Gug and then you can keep transcending it and it look at all the keywords that have been typed in and create a custom Gug based off of it. So you could type in turtle, and then after that you could type in fire, and it'd give you a fire turtle. But then we realized once you hit 3, it's just this mess that no one knows what's going on. If you type in turtle, fire, and lamp post, the ability is so meaningless at this point because there's so much going on. So a big design decision was actually restricting it to a single phrase, and you can't transcend on top. And then that way players can really see the relation between what they've typed, the effect, and the image.
This kind of reminds me, I don't know if you guys have seen these videos where people put things through Google Translate 10 different times, and then it's a recipe or a song, and it just doesn't make any sense by the 10th time.
That's a really good analogy. Yeah, at this point you're what even is your ability supposed to be once you've typed in 5 different contradictory words?
Kamen, did you have anything to add? Sorry, kind of just put it in with the Google.
It's quite similar to what Marlon was talking about. There's a larger issue of communicating the right information to the player. We initially wanted to have a lot more Gugs and a lot more interactions on the battlefield, but very quickly found that it was just becoming an incomprehensible mess. Right, if you imagine having 100 Gugs on the battlefield and each of them doing their own thing, players get very quickly confused. Right, so we actually found that even though the technology allows you to do incredibly large-scale simulations, from a player usability perspective, from enjoyment, you actually want to constrain it to very few things happening at once, so that the player can make sense of them.
In most TCGs and deck builders, you have a limit to the number of cards, right? So a player can learn throughout their runs what cards do, right? So they can just visually look at a card and know its effect. But in Gug, because it's always growing, conveying this information to the player, right? Because I've always seen new Gugs and not making it tedious and feel like a task and hurting the player's brain. That was a pretty tough kind of UI challenge to overcome that we're still working on. We have some stuff for the full game we want to add in there to make it even easier for the player. But it's infinite learning almost for the player. So it's getting that information across to them quickly in a way that's understandable and not boring was a pretty tough task.
Is there any message you'd like to leave for those who might be reluctant to try the game because it uses AI?
We're using the technology of AI to just create more powerful procedural generation. People are fine with procedural generation, they're fine playing Minecraft, right? AI now just enables us to procedurally generate larger pieces of a game, and therefore allowing players to have a more personalized experience.
On top of that, I mean, the one thing we set out before from the beginning is using it in a way to make something that you couldn't necessarily make without it. Right, we're not just like kind of like slapping it around the place. We definitely wanted to make a game that incorporates it so tightly and in such a way that you like this game couldn't have existed prior to this technology.
So as you can see, the AI tools used in the development of this game were just that, tools, implemented with the intention of creating something new, unique, and fun for the player. It is not simply AI slop as many Twitter users might assume, but a game developed out of genuine passion and creativity. And as Kamen said near the end of the interview,
GUG may be the first thing to do these things, but there's going to be a lot more games that adopt this technology, and I personally think that's super exciting.
And after hearing these two talk about their game, I feel a lot more at ease about AI being used in video game development, especially in the indie department, where it's not so much about cutting corners and saving money, but about using the tools available to make something unique and fun to play. And that's my thoughts on this topic so far. Please let me know what you think about AI in video games in the comments down below, as I'm always interested in learning more and hearing others' perspectives. Just remember to be kind and respectful towards others. If you want to try out the game for yourself, you can find GUG and try out the demo on Steam, or just get the full version of the game when it releases in July 2025. By the way, it is not a sponsor, it's just a cool example of how we might see AI implemented in the future of video games, so it might be worth checking out just to get a better understanding yourself. Either way, thank you for watching, I hope you learned something new, and I'll see you in the next one. Bye!